to this tutorial on redox reactions in acid solution. Today we're going to do this problem using our clever checklist here, doing it step by step to get to this very complicated looking solution. So our first step is to assign oxidation numbers to the atoms. So as you may already know, oxygen is -2 and hydrogen is +1. So since the rules of the oxidation number state that alone standing atoms have an oxidation state of 0 or the oxidation state of the ion, this chromium has an oxidation state of +3. Now, if you multiply these numbers by the number of oxygen or hydrogen atoms, you'll find the following oxidation numbers for chromium and phosphorus. Now, having the oxidation numbers, we can go to step 2 and divide the half reactions by oxidation and reduction. If you look at the first compound, the phosphorus starts with an oxidation number of 1 and ends with an oxidation number of 5, +5 and +1, so it loses electrons. Remember the rule oil-rig, oxidation is losing. So this is our oxidation reaction, and the chromium is our reduction reaction. Alright, coming to the next step, balance anything except O or H. So we're not going to look to the O or H's, just balance anything except it. So here the phosphorus is one phosphorus here, one phosphorus here, so that's the same. But the chromium we have to balance in this reaction. So we have to put a 2 in front of the chromium to have the same amount of chromium atoms in this reaction. Now, to come to step 4, we're going to balance the O's with H2O and the H's with H+. This is because we're in an acid solution, we have to balance the reaction. So, let's calculate this. So we see here we have 2 oxygens on this side and 4 oxygens on this side. So sticking to the rule, we have to balance the oxygens with H2O. So I'm gonna add 2 H2O on this side. Now, same for the second compound. We have 7 oxygens on this side, no oxygen on the other side. So I'm going to balance this with 7 water molecules. Alright, now we have to balance the hydrogen with H+. So again, we're going to count with 4 hydrogens here, plus 3 is 7 hydrogens here, and 3 hydrogens here. So we add 4 H+ on this side. Here we have 14 hydrogens, so we're going to add 14 H+ on this side. Okay, so our next step, step 5, is to balance charges with electrons. If you look at the first half reaction, you see that it has 4 positive charges, which means we have to balance it with 4 negative electrons. For the second half reaction, we have the chromium here, which is an ion. It has a positive charge. In fact, the positive charge is 6 because we have 2 chromium ions here. And on this side we have 2 negative charges as well. So you might assume that we have 14 electrons here to balance the reaction, but actually we want to get 6 positive charges as a result. So you calculate 14 minus the 2 charges, which are already added, it's like adding electrons, so this is 12. And then you want to get from 12 to 6. So you only add 6 electrons here. Okay, so now we're already done, but still you have to, if you look at the 2 half reactions, with a different number of electron input and electron output. And the number always has to be the same in a reaction. Alright, looking at our clever checklist, we see that step 6 is to balance lost and gained electrons. It's very important that you balance electrons on the reactant side and on the product side, because they have to be the same. So now we see that we have 6 electrons on this side and 4 electrons on this side. We need to find the smallest common multiple of these two and multiply the whole reaction by it. So the smallest common multiple would be 12 in this case. So we multiply the oxidation reaction by 3 and the reduction reaction by 2. So 2 times 3 is 6. So 2 times 3 is 6. 1 times 3 is... little basic math lecture here. So now that we have balanced our reaction, as you can see we have 12 electrons here and 12 electrons here, we can come to our final step 7 to sum the reactions up. So I've already written it down. So for the reactant step you only look at this part, so really at the reactants of both of the reactions. And for the product part, you look at this part for the products of both of the reactions. So as you can see, I put this in the final reaction and this in the final reaction without changing it. For the product side, I put this here, I put this here, and now we have the water. So we're left with the water. And you can cancel out this water here and subtract 8 by 14 and you're left with your 8 water molecules here. So that's it. I hope you enjoyed the video and make sure you also watch the other ones.